Hello everyone, Sean here from Crown Technologies. We help people reach their goals with the best clean power, air and water system. Today, my video is addressed to all of my commercial and residential cooling prospects. We're going to be discussing the NATA Test Laboratory report, and what this is a report that Sealy International, who is my primary supplier, asked the National Australian Testing Authority to compile. As I understand it, the cost of this laboratory and the entire process was approximately $1 million Aussie dollars. So it's not a small amount. And part of the reason is because of the false claims that so many of the opposition had been making against the Sealy International coolers, the Breeze Air coolers and the Cool Air coolers. So what Uncle Frank did, and he's still the sole owner of Sealy International, is that he approached NATA and said, I want you to test a bunch of these coolers. I'm going to help you put together the laboratory so that we can simulate all the exact same conditions. There is the floor plan of the laboratory. And let us see whether or not what you guys pull out is comparable to what the manufacturers are claiming. Let's take a squiz at what some of these units are claiming. Manufacturers, here we go. One of the prominent makes here in South Africa is the Kerry unit, KD18A. That is a fairly prominent serial number that you'll see on. It'll have a couple of different brands. I think Windmaster International uses it. I think Aquabreeze uses it, and I've seen a couple of Cell Air units with a similar designation. So the claimed airflow is 18,000 cubic meters per hour, and what the laboratory found is that it is significantly less, not 10%, 20%. This is about half. Right, so the Kerry KD18A claiming 18,000 cubic meters per hour, delivering 9,100. I know Airline is one of the better ones, claiming 18,000, delivering 10,890. Now, for me, as a customer and as somebody who is looking to win the trust of end users, you've lost my trust just by this level of misrepresentation. And let's take a squiz at some of those brochures. Here we have, I think this is the Cell Air. The claim is 18,000 cubic meters per hour airflow from a motor size of 1.1 kilowatt. Then we have the Aeolon. Here we go again. Claimed airflow 18,000 cubic meters per hour from a 1.1 kilowatt axial fan. If we have a squiz at the Kerry catalog, this is where it gets really, really interesting. I'm going to pause on that. When we understand cooling capacity, it's more than just the breeze. How cold is the air that's being delivered into the building? And that, coupled with the airflow, gives us a cooling capacity design in kilowatts. Right? So a better machine that is put together better will deliver colder air at a similar airflow, but will therefore have higher cooling kilowatts for the same airflow. I hope that makes sense. It makes sense in my head. So if we take a squiz at the TBQ, you will notice that this has a excuse me, a fan motor of 950 watts, and it will deliver, after 80 pascals of pressure losses, 10,120 cubic meters per hour. This is another very, very helpful telltale. Any manufacturer, any brand, the first thing you should ask them is, can you show me your cooler's performance on a fan curve graph detailing the losses of static pressure and what will that delivery be? That kind of tends to separate the men from the boys, so to speak. All right, so there we have it. That is the delivery point. And what does that translate to in cooling kilowatts? Well, under the conditions that the NATA laboratory ran their tests at, which is ideal for Australia, 38 degrees dry bulb, 21 degrees wet bulb. These are relatively higher than your typical Gauteng temperatures, but these might be comparable to an average free state condition. So those are the test conditions under which these cooling kilowatts have been measured. So this unit with a 0.95 kilowatt motor at an airflow of 10,120 after 80 pascals of pressure losses is delivering around 14 kilowatts. Let's have a squiz at what Kerry claim. Their claim is with a 1.1 kilowatt motor at 18,000 cubic meters per hour, which we've already seen to be proven false. Their claim is a cooling capacity of 43 kilowatts. This blows my mind. The audacity of such a claim is just overwhelming. What is the truth of the matter? What does the laboratory's test report say? Your Kiruli KD18A is delivering 7.9 kilowatts of cooling capacity after claiming 43. After claiming 18,000 cubic meters per hour, they're delivering 9,000 cubic meters per hour. This should ring all the warning bells that you as the end user need to know. So here's the whole graph. You can take a squiz at this. The engine, if you will, that delivers that cooling capacity is often the media, the quality, and the size or the surface area of the cooling pads. Again, Breezer is my plumb line. This is one of the best and most well-known units in South Africa for probably about the last 25 years plus, is the Sealy International, the TBQ 550. You'll see them on a lot of the CTM buildings. I think there's a national contract out. If you take a look at the surface area of the cooling pads, there you can see it's 850 by 526. It gives you a total pad surface area of about 1.79 square meters. So this is almost the actual size, the displacement of your engine. So this is like a 1.8 liter. When we compare this to the Crown Technologies Cirrus 6000, you will notice here I've got a 2.3 kilowatt motor. It's a variable speed drive. I can build them in single or three phase. And my surface area for my cooling pads is 4.66 square meters. So what we've also done, we've done quite a bit of mathematics over here, along with test conditions. There's two different methods to calculate your cooling capacity in kilowatts. One method brings us out to 29.4 kilowatts of cooling in Johannesburg, and the other one brings us out to 28. So let's be safe and say that for 2.3 kilowatts of input energy, single phase or three phase, I will give you reliably, consistently, robustly in Gauteng 28 kilowatts of cooling. At 25 air changes per hour at 3 meters high, this will cool an area of approximately 250 square meters. At 35 air changes per hour, this will cool a space at 3 meters high of approximately 175 square meters. Okay, so know your cooling, know your value, the value of the cooling and how reliable it is, and how long you could expect the system to last. Guarantees is obviously another very, very important scenario. And what we've done is, again, we love Sealy, and we think that their guarantees are fair. We have modeled our guarantee program on theirs, which is a 25-year guarantee on your cabinet. That's why ours are made out of 3 or 4 stainless steel, 10 years on structural components, and 2 years on your major components. All right, so I hope this video has been helpful, especially for procurement officers, right down to the local homeowner, guys that are trying to figure out, one cooler is selling for 15,000 Rand for the cooler, the other cooler is selling for 35,000 Rand. How do we make heads or tails? Who's telling the truth? I hope this video has been helpful, and we look forward to helping you reach your goals with the best clean power, air, and water systems.